Hi everyone. So I think till now everyone has understood at least the basics of ML, right? What is supervised and what is unsupervised. So that is very important in upcoming, you know, uh, to solve the real uh, problems, right? Yeah. So supervised, I'll just recap again. So supervised nothing but involves you training a model on the labeled dataset, right? So where the algorithm learn to map the input data to the corresponding output labels. And whereas unsupervised learning is nothing but it deals with unlabeled data, right? So there is no labeled data here. So this algorithm in unsupervised explore the structure of data to find the pattern, grouping, and so on, so right? Maybe do the clustering, market segmentation, and so on. So in summary, what we learned, supervised is all about learning from the labeled examples, and unsupervised is about the discovering the patterns or relationship in the unlabeled data. Okay, so I'll just open a dataset. Okay, so this is one dataset looks as this is the format of CSV file. Okay, so these are the number rows we have, right? Passenger ID, survived, P class, name, sex, age, sibling, spouse, barge, ticket, fare, cabin, embark. So these are, we say these are the columns, right? So we say these are the futures we have, futures, okay, in terms of ML. So futures in the sense these are the row, or we can say column name, right? So this column name we represent as futures. Okay, so this is nothing but data set of Titanic data. So here I'm actually predicting whether this Titanic ship, right, how many passengers survived or not survived. So when I am just considering this future, it is in the format of zeros and ones, right? So it is in the format of categorical variables. So categorical variables means so which we can actually count, right? So that will be format of M, F, male, female, 0 and 1, right? Maybe some other number, so maybe 1 and 2, something like that. So such kind of variables we say it as categorical variable. Okay, so this is a type of variable. Again, we can take on this value from to represent different categories or groups, right? So again, this categorical we have something called nominal variable and ordinal variable. So this nominal variable is something like gender, right? So or consider some rank, maybe first rank, second rank, third rank, something like that. So we consider it as nominal variable. That means a categorical with there is no inherent order in that. Okay, whereas we have something called ordinal variables. So ordinal variables are something like this category has some meaningful order. So consider when I'm doing my schooling, right? So I have high school, bachelor's, master's, and so on. So or something maybe coming to the customer satisfaction, I have something like low, medium, high, right? So such kind of variables we say it as ordinal variables, and in categorical variables we have nominal variables and ordinal variable. Okay, just for your understanding. So just for your understanding, this is the data set of Titanic ship prediction, right? How many passengers survived or not survived. So this 0 and 1 represent the dependent future called survived. So this dependent future is dependent on all other features. So this survived future is dependent on all other features. That means survived feature is dependent on P class, survived feature is dependent on name, survived feature is dependent on the gender, survived feature is dependent on the age, so on, so right? Yeah. So again, this sex, right? This is the male and female. Again, this is one of the categorical variable. And coming to the P class, so when I'm just filtering it out, so it says I have only three filter, right? 1, 2, and 3. So that means, so it is again a categorical variable, right? Yeah. So this categorical variable can take values from a limited set, that is fixed set of categories or group, right? Yeah. When I coming to this passenger ID, here we have different numbers, right? So here we have lot of values, like it represents how many rows we have, right? Around 891 plus. So that means it is not a categorical variable. Okay, got it? Yeah. And coming to the name, again this is not a categorical because we have a lot of plenty names available here. Again age, so we have a lot of age groups, right? So lot of age group. So it is not even a categorical. Again, sibling spouse. So here we have values only from 0 and 1, 1, 2, 3 as well, right? So that means it is a categorical. Coming to parch. So again, this is 0 and 1 and 2. Again, this is the categorical. Coming to the ticket number. So this ticket number varies from passenger to passenger. So that means this is not a categorical variable. Okay. Coming to the fare. So again, this fare changes from the person that is traveling from one source to destination. So again, this fare keeps on changing, right? So that means this fare column is not a categorical variable. And again, this cabin keeps on changing. It is not a categorical variable. Where this embarked, if this embarked, we have something called three labels, that is S, C and Q, right? So that means it is a categorical feature. So this is categorical, this is categorical, this is categorical, P class is categorical, survived is categorical, right? So we understood now what is categorical variable now, right? I hope you understood. So if we consider our dependent feature that is survived here in our sort of example for this data set, so we have identified what is the dependent column that is survived. So this dependent column, whether we will find whether it is a numeric format or is it categorical. So it is in categorical format. Directly we can go ahead and implement the classification algorithm. So that comes like logistic regression, decision tree, random forest and so on, right? So now we'll just see how we can go ahead and just do some sort of data cleaning around, right? Yeah, for this Titanic data set. Okay, so yeah, so these are the libraries that you need to focus. There is something called pandas and numpy. Okay, so pandas is basically to read our CSV file. So just now we saw our CSV file, right? That is nothing but titanic.csv. So this CSV, how can we read it here, right? So that's how we use pandas library, okay, to read the data set. So again, this pandas library is most popular, right? It is again the open source used for data analysis and for data manipulation techniques. Okay, so using this feature we can actually clean the data, like we can actually sort different indexing here and there. We can group the data, right? And we can also read the CSV or Excel file or whatever it is, right? Or SQL database, that is also possible, right? So this pandas, just for your understanding, this pandas is widely used in data science, machine learning, okay, used for exploratory data analysis, doing cleaning, EDA and all. Then we do for data wrangling techniques, okay, and it is very easy to use. So directly we can go ahead and import pandas as PD and you can actually use this. So this PD we will be initializing it pd.read underscore CSV, and here you need to give the path. So this is the name of the file, right? Titanic data 1.csv, and here you can actually change the path. So consider you are opening something from your direct desktop, alright, so that means it will be C user slash the name and the location, right? So that complete path slash CSV file, so that will be the path you need to give, okay, and always remember it should be the forward slash, okay. So that is how you need to fetch the path here. After fetching the path, you can actually call this Titanic data.head. Head is nothing but to fetch the first 10 rows, okay. So that's why we use head of 10. To consider, you need to fetch first 20 rows here. So that means Titanic data.head of 20 you need to use here, okay. So from this data set, I'm just understanding, okay, what will be my length of the complete index, right? So it is very simple. We use print of some name, right? String of length of Titanic data.index. So here we have initialized Titanic data as a variable. We just declared here, right, to call to read the CSV file. So this same name Titanic underscore data we will be using in all other steps, right? So here we use length of Titanic data, so same thing, right? This complete data set, it is here length of complete data set dot index. So it says there are 891, okay, 891 rows of information we have. Okay, so next I'm actually analyzing the data. As I said, in pandas we can actually analyze this data, right? Analyze in the sense, from this data set we can actually find what is what, right? Maybe from this data set what all we can find, we can actually find what is the age group, right? Who has traveled in this Titanic ship, right? What is the highest age group, what is the lowest age group, and what is the highest fare that passenger has paid, which direction they are moving to, right? Which passenger is moving to highest count of to which direction, and yeah, which passenger class they are traveling, right? Passenger 1 2 3, even in train and all you can find, right? AC coach 1 tier 2 tier 3 tier, so something like that. P class, passenger class 1 2 3. So which class the passenger has traveled mostly from in this data set, something like that. So this is something like we are actually doing some sort of analysis using our data set. Okay, so that's why this data analysis is very important. Before directly you cannot go ahead and build some model, get some accuracy. That is not our aim, right? So we need to understand, like we need to define the problem, like we need to clearly understand the purpose and the objective of his analysis, right? So as this data cleaning, so we need to see, is there any data cleaning or some sort of pre-processing is involved or not. Then we will actually do lot of cleanings around. So here you can actually see a lot of missing values and all, right? See a lot of missing values and all. So this and all we will actually clean it, right? Before going and doing some machine learning algorithm, right? So a lot of statistical analysis we need to use, right? So statistical methods are there, you need to learn, especially to derive some insights from here, right? Then we'll actually validate the model, we'll actually perform some modeling, right? Some predictive modeling like machine learning, various machine learning algorithms are there, right? So we need to use that, and further these insights can be gained from the complete analysis to do some decision making around, right? So that's about the once you get the data set, these are the steps that you need to follow, right? Simply you cannot do and create some ML algorithm and get some accuracy. That is not our ultimate aim, right? Our ultimate aim is to bring some insights from our analysis, so these insights we can actually support some decision making, right? And we can actually provide some recommendation based on our findings. So that should be my aim. Maybe till data collection, till the model deployment, you need to be familiar with all the steps. So a lot of things that we use, especially for data cleaning, understanding data, a lot of data analysis we need to use at initial stage to understand the data, how my data set looks like, and so on, right? Yeah. So from this data set, let's see what kind of analysis we can use. Okay, so we have something called import Seaborn as SNS. Okay, so Seaborn is nothing but it is a visualization tool, right? Visualization library that we actually use. Okay, so using this Seaborn, it supports like a lot of statistical plot we can actually support, like scatter plot, line plot, bar plot, and so on. So right here it says count plot. So this SNS, we are this is how we need to import Seaborn as SNS, and this SNS dot count plot we need to call, right? And we need to specify like which is the column that we need to do the analysis for. So x equal to, that is x equal to survived column, right? So what I'm doing is, for this survived column, that is our dependent feature, I'm actually finding we have 0 and 1, so which is more, right? In my data set, 0 or more or 1 or more. So here I can find 0 or more, that means passenger didn't survived is more in our data set than the passenger was survived, right? That is 0 is more, right? So using this Seaborn, right, so we can actually perform lot of statistical plot, including scatter plot, line plot, bar plot, histogram, and so on, so right? So that's why this just using one line of command we can actually visualize. Okay, so XNS, that is nothing but Seaborn importing, right? Import Seaborn as SNS. Same SNS we'll be calling here SNS.count plot, and we will be specifying what is a column that we need to suppose to do the analysis for, and data equal to, we need to give the call the data here, right? So Titanic underscore data. So this is CSV that we just imported, data equal to Titanic data. So just in one line of command we'll be getting this kind of graph for further analysis. Okay, so this count plot is nothing but it just count, right? It just count, based on, so we have two categories here, 0 and 1, right? So this count plot specifically what is that is just specifically check like which type of plot is supports here for this categorical variable. So it automatically says yes. Here it displays the number of observation, right? 0, it is crossing some 500, and 1, it is near to 350 something, right? Yeah, so it also says like what is the maybe occurrence of this count, right, of this unique categories of 0 and 1. Okay, yeah. So next, for the same thing I am actually performing for two different columns, right? So sns.count plot x equal to survived, that is my first column, and HUE, right? HUE I basically, what is that is in the sense like we can actually allow this particular parameter to introduce an additional categorical variable to the plot, right? So consider, I want p class, so instead of this x I can actually write p class as well. So this is a format that you need to this is kind of syntax, right? xns.count plot x equal to HUE equal to data equal to which data we are actually referring to, like which CSV we are referring to. So here we can actually here in this syntax, what we are actually doing is, in this code what we are going to do is we are actually finding, okay, based on the survived column that is having 0 and 1, okay, introduce my additional categorical variable, something called sex, with respect to that, and give me the analysis with respect to the survived column. So that is nothing but 0 and 1. So 0, it is checking male is more, that means survived, passenger not survived, male is more here, right? And passenger who survived, the female is comparatively more, right? Such kind of analysis we can actually get from this kind of count plot visuals. Okay, so next further visuals we can actually see, we have introduced to p class. So here 0 and 1, so that means passenger not survived, so that means the passenger third class, most of the people has not survived, right? Whereas survived, I could say passenger 1 has survived, right? Most of them are survived here. When I'm checking some sort of percentage, which is more and which is less, so just using the count plot, it actually helps, right, to identify which is more and which is less. Next, I'm actually finding Titanic data, just finding the histogram. Okay, so this is how we need to write Titanic data. That is the name of the CSV we just imported, Titanic underscore data. From this, what I need to find is I need to fetch the age column only, right? Titanic of age dot plot dot hist. So what that is, it just give a histogram representation. So histogram means it just give the distribution of the data set, right? So it divides the data in different bins, right? I think you know. So what is histogram? It divides the data into bins and display the frequency, or I can say displays the count of observation falling into each interval. So here I can say age group between 20 and 25 is more in my data set, right? So such kind of analysis we can actually get it from this histogram, right? So this histogram displays the frequency or the count of the observation falling in this each interval. Okay, so again I'm actually finding and doing just these bins I'm actually changing with different colors, that's it. So even actually I'm giving the how many bins I want, right? Here I can specify as many as bin I need, right? Bins equal to 5, and which color, sky blue, or if you want some pink color, blue color, orange color, whatever you can actually change here. Okay, and actually just plt.show, so show that particular graph, that's it. Just a single line of code. Okay, so here again I'm finding how many bins I want, and according to p class, here I have one p class 1, p class 2, and passenger class 3, right? So based on that, just specify me, that's it. Okay, next I'm finding the fare, histogram for the fare, right? So it again displays the frequency of the count of observation falling in this particular category for fare. So here we can say most of the passenger, so my understanding was most of the passenger was Yeah, majority of the passenger was in third class, right? So that we actually got it here, because from this data we can from this graph we got most of the passenger traveled in third class, right? So that understanding we got, and we can actually see fare. A fare is comparatively less they paid, right? So let's check. No, coming to this data set. See, most of the paid less fare, right? Less than 50 only they paid. Most of them. See some. There are some outliers. So this kind of outliers things are there, which is value very separated uh, from the other values, right? But whereas no, most of the values we can say most of the fare values in between 0 and 50, right? So most of the passenger traveled in first class, third class. So that means they have paid less fare, something like that. So I can actually correlate with this and that, right? Yeah. So that's how you need to do the analysis for your use cases. Okay. Yeah. So next I'm just finding Titanic data, like underscore data, the CSV files which I just imported .info. So it just give, if I give .info, just give the all the information with respect to our data columns. Okay. So it's space like for this particular column, right? 891 is the total number of values that I have. It is a non null, that is an integer value, right? So coming to this age again it is a float. Name it should be a string, right? So that's why it is a object. And cabin it is again a string, and embarked again it is a string. Okay. So here we can actually see 891, right? So that means there is no missing value here, right? Because we actually checked what is the length of the data set. So it is a 891. Okay. So when I'm doing some kind of .info to fetching the all the other columns information, it says 891. But when I'm coming to age, it's it actually dropped here, right, from 8191 to 714. And cabin also, see, again it dropped. So there is some problem in age and cabin, right? So just I'm opening my data set. So age and cabin are some, see, lot of missing values are there, that is lot of empty values are there, right? So that's why age and cabin. So see, cabin also has lot of missing value, right? So these are the kind of empty values. So definitely when doing some analysis we need to fill this, right? Because if we didn't fill, what happens, the value or the model performance whatever we are doing in ML, it won't be that accurate. So that means yes, definitely we need to do some sort of additional steps, right, to clean this data. So that's why all this comes in EDA, exploratory data analysis. Data cleaning we need to do is some imputing some missing values. Imputing means wherever these missing values are there, either we need to fill with some sort of values here. So that's why statistics is very very important. Okay, in terms of when I'm speaking ML, right? So that's why we can say statistics is the base here. So without having this statistical knowledge, definitely we cannot go ahead and do some inference, or we cannot go ahead and do some modeling or model evaluation, whatever, right? So that's why data pre-processing is most important step in industry point of view. We need to spend most like 60% of a time only for data cleaning purpose only, right? So that's why statistic is nothing but, we can say it is nothing but the foundation of this ML, right? Because it actually tells, like, to understand the data, making prediction, to assess the model, everything we need statistics, right? Yeah. Okay. So here I am just still in the count plot, right? Yeah. So it says I am some missing values here, right? So age and cabin. So let's see further step what all we can see. Okay. And again in this particular tutorial, we just discuss some analysis part in depth. Okay. Again the count plot. So sibling spouse, that is the column name here, sibling spouse, right? So this particular column, again I'm doing analysis. So sibling spouse, which is more here, right? So that means 0 is more compared to other, right? 8, 5 and at least one is next side of 0, right? Yeah. Next, I'm actually finding, as you see the which all columns as empty value, missing value, age and cabin, right? Yeah. So I'm just finding, okay, that Titanic data, that is a name, how I read dot is null. So if I do the is null technique, it says is there any null value that is associated for for each particular column, right? So with context to data analysis and manipulation, okay, this is null is nothing but it checking the missing value or the null values in the data set. So just see, wherever it is null value, it says true, okay. So that is nothing but cabin, it says first value is true. Okay, let's go ahead and verify. See, first value is true. That means it can actually check whether this particular column the first value is missing or not, just using the is null. Okay, so just using this is null, okay, we can actually check is there any missing values in here in Python itself. Okay, see, all these are missing values, true and all, right? See here also true, we have observed in age, right? It won't display everything, but definitely we can, using the additional code, I'm using dot is null. With this I'm finding dot sum, that's it. So it says for age I have 177 missing values, cabin I have 687 missing value, and embarked column I have 2 missing value. Have you seen it, right? So that means most of the missing values are in cabin column, right? Yeah. So next I'm finding the heat map. Okay, so heat map is nothing but here you can see some white dots, right? So with respect to this missing value, I can see the cabin as 687 missing value. So that means it says, right, just a heat map visuals, right? It represented by like this, right? A kind of visuals, white colors, right? So that means cabin has more kind of missing values here. Heat map of I'm just checking data set dot is null and white tick labels equal to false. So what I did, that is particularly visualize the magnitude of these colors, right, in the two-dimensional scenario. So it's give age has some missing value, but cabin has more. That means white colors are more here. From this visual we can understand like that. Okay, just going for other analysis, box plot. Okay, so this box plot is nothing but it just give the count, right? So here with respect to p class and survived column, okay, so it says okay, what will be my box plots, right? So again, this very simple. So box plot is nothing but it gives the distribution of this representation of the data set, right? So in the year we can actually check, is there any outliers in my data set, is there any so all these are the statistical measures using something called median, quartiles, outliers. All these actually we use in box plot. Okay, I'll explain in further analysis, but this visual is not clear to understand for box plot. Okay, let's see. Okay, let me just Google it and explain you what is box plot from the visual itself. Yeah, I'll just open this. Okay, see, when I'm getting such kind of thing, okay, so this is the thing we call it as box plot. Okay, so it says what is the minimum value, what is the maximum value, and what is the median value. Okay, so consider my data set something like far. Okay, so far has values from 0 to 100. Okay, so in that case 50 will be the median. Okay, got it? So minimum is 0 and maximum is 100, right? So consider in the far I have something called 1 lakh also. Okay, someone has entered the data incorrectly, consider like that. So in that case this 1 lakh is nothing but it is an outlier, right? Because my most of the data points are from 0 to 100, but considering my data set called fair, there is something called 1 lakh. So definitely so this kind of 1 lakh, so that kind of point we call it as outlier. Okay, so just no, I need to explain this now. Okay, yeah. So you understood the box plot, right? So here we have median value, quartiles, and we can actually find the outliers as well. So here it says P class I have 1, 2, 3, but in third class I have some outliers. So that's what this visual represents. Okay. Yeah. So next, again, this again the count plot with two different columns, survived and P class. So here it says passenger didn't survive. The passenger 3 is most of them, right, who has not survived, whereas passenger who has survived, most of them are from passenger 1 class. Okay, that means 1 represents to this blue, so blue is more, so that means passenger 1 is survived from my data set, whereas passenger 3 didn't survive from my data set. Okay, yeah. Yeah, again this is same thing what we just saw. Using this, we are actually using something called facet grid in top of histogram. Okay, so this facet grid, so as I told, we have a lot of different visuals we can actually do for this analysis part. Okay, so this facet grid is nothing but, again, this suppose the seaborn library, right? Again, it is one of the very powerful tool, right, for creating the multiple plots and all. So with multiple plots, so here we'll be getting in one single chart, we'll be getting two different visuals, but here we'll be getting the separate charts here. So that's the powerful of facet grid. Okay, so again we can say each subplot represent a different category or combination. So this category represents survived equal to 0 for age, and this particular visual represent the survived combination, survived one combination, right, with respect to age. Okay, so that's a difference. So using the facet grid, for which column will represent to survived column, from the survived column I need to get the age for the histogram representation. So it says survived equal to 0, age is in between 0 to 30 something, right? So and survived, who has survived, age group are most in between 20 to 35, right? So that means 20 to 35 age group, most of them survived in my Titanic ship data set. Okay, okay, got it. Yeah. So next, using again this facet grid. So again this facet grid is powerful tool, right, for creating the multiple plots and all. So using C, when I'm just using the count plot, it says in one visual it gives the two charts, right, in the combined format. But whereas in the facet grid, what does it give? We can actually share the same structure, right? So with respects to different kind of subplots. Okay, so here each subplot represent a different category, right? 1 and 2 categories of combination or different type of categories here. Okay, so some kind of analysis again we can actually do. We can actually change this alpha value, change the bin value, how much we want, and all those. So bin value is nothing but again this small part, we say one bit, right? 1, 2, 3, 4, 5. So that's why we specified 5 bins. Okay. So okay, so again what I'm going to do is here is from the survived column I'm actually finding what is the age group, right? Most of them. So 1, 2, 3 classes I have. So from these 3 classes, like, get me the age group, right? So most of them, see, for the passenger 3, most of them are in between 20 to 40, right? Yeah. So some kind of analysis we can actually bring from this kind of analysis. Again this other chart. Okay, so a lot of charts you can actually build upon, but just for your understanding, you can just take your data set and keep playing around, changing with different columns. So definitely with you will be getting some analysis of meaningful charts around. Okay, so again the facet grid, on top of this I'm using the point plot. Okay, I didn't use a histogram, I use the point plot. It says like point to point what is what, right? So in embarked I have SC and Q, right? So it says like coming to this passenger class, like which are the points that are coming top, right? So which female and more, which is more, something like that we can actually find, right? Yeah, some sort of analysis. Again I'm using facet grid on top of bar plot. See, again this again has some analysis, right? Q, so embarked Q, most of them has survived with respect to C and yes, right? Yeah, some analysis again. See, you can actually play around with this. Okay, next, yeah. So we have actually find, okay, so that's about analysis. So you can actually there are a lot to discuss. Even next class we can go ahead and do some plotly visuals, and let's see how plotly has a lot of interactive visuals that you can build around. Okay, yeah. So again, this analysis, again, lot of analysis we can do around. Okay, see, again we have something called cabin column here, right? See, and instead of imputing some missing value, now I'll show you how you can drop this column directly, this cabin and this age, okay, directly. Okay, so this Titanic dot data dot drop, fetch me, that means drop the cabin column, right? And axis equal to 1, that is, fetch row wise, right? So the axis equal to 1 implies equal to true. So that means this particular cabin is deleted. So when I'm do the Titanic data dot head, again it says C. From this data set we don't have the cabin, right? Because this cabin column is already dropped, that is deleted here. Okay, so yeah, next about heat map finding, so the same thing. Okay, yeah. So we have something called, okay, in gender, okay, we have something called male and female. So always remember, okay, all these are strings, right? Male, female. So when we are actually building some ML or ML modeling, okay, we need to get in the format of encoding, right? So that means we need some integer values. So without integer value we cannot go ahead and do the machine learning modeling. Okay, so what I'm going to do now is, okay, we have something called male and female. This male and female I am converting to 0 and 1, that is 0 for female, 1 for male, something like that. Okay, for my analysis. So always remember this, we use something called get dummies. Okay, so get dummies is nothing but it is a commonly used for one hot encoding categorical variable. We have something called male and female, or something called high, low, medium, something like that. So like that also we can actually give 0 1 2, something like two different categories. So here in the gender sex column we are converting male and female to one hot encoding techniques. That is nothing but it converts the categorical variable, that is nothing but male and female, to the binary vector. Binary vector means some numbers 0 and 1. Okay, that means it requires a numerical input. Why we require numerical input? Always remember, ML algorithm always require a numerical input to create further analysis. Otherwise, if it is in the string, it won't understand. Okay, so that's why doing this one hot encoding process is very important to convert the categorical variable into the binary vectors. Okay, so here I have seen this one I just converted, right? So again I just need only one. See, either I need to, here I have only male and female only, right? So either I need 1 or either I need 0. It is automatically understood, right? Male 1, that is female 0, female 1, automatically male 0, right? So that's my, I am just dropping the first is true, get me only the male, right? So then I'm doing the get dummies for embarked also. So embarked we have S, C and Q, right? This string we need to convert to the numerical input using the one hot encoding. So S, C and Q, again I'm just converting to 0, 1, 2. Okay, like this. So we will be converting. Okay. Yeah, here we need only two conditions. Okay, why? Because if Q is 0 and S is 1, automatically we can understand C is 0, right? If we have Q 0 and S is 0, we can understand C is 1, because there is only one, right? Yeah, either we consider this. So yeah, either we can actually understand Q 0, S is 1 and C will be automatically 0, right? Because only one will be there when we are converting to numerical, right? Yeah, so I hope you understood, right? So we are dropping the first dropping the first value. So that is nothing but C will be dropping, because we need only 2. In here we 3 require 3, we need only 2, but here we have male and female, we require only 1. Okay. Yeah, next I'm actually dropping this. So which and all, it is not important, I can actually drop. Okay, just to show you the syntax wise. Drop access equal to 1, in place equal to true. So wherever it is this sex, embark, passenger ID, name and ticket, automatically these columns are being dropped from my data set. And additionally, I have created this, right, 2 3. So 2 3 and QS will be added to separate columns. So that's called some sort of EDA we did, right? Yeah, using one-hot encoding. Again, I just dropped the P class. So that also you can do. Okay. Yes. So this is about the data cleaning, and the model evaluation will be learning further. Okay. So I think from in this the today's I could say this section you understood. Yes, how we need to do the analysis. We use Seaborn library, right? And what if there are missing values, how we need to find, is there any missing values, using dot is null dot. Some lot of charts we have seen, right? We have also understood different chart, count plot, box plot, bar chart, and so on, so right. And about the pandas we have learned. Then we have also learned about the categorical variable, if it is dependent, if it is categorical, which ML techniques we need to use, and so on, right? Okay, next we'll be continuing in the next section. Okay, yeah, thank you.